August 15th, 1977, 11:16 p.m. The Big Ear radio telescope in Delaware, Ohio picks up a signal. No one is watching. The telescope runs automatically. It prints data onto paper in real time, columns of characters, numbers, and letters, each representing the intensity of radio waves received from space. The next morning, astronomer Jerry Ehman sits down to review the printout, and he sees something that makes him reach for his pen. 6 characters, 6 EQ'd UJ5, a spike in the data so perfectly formed, so precisely matched to what scientists had long predicted an alien transmission would look like, that Ehman circles it in red ink and writes one word in the margin. Wow! No one has explained it since. The Big Ear telescope was part of SETI, the search for extraterrestrial intelligence. By 1977, SETI had been scanning the skies for over a decade. The premise was simple. If there were intelligent civilizations elsewhere in the universe, they might be broadcasting radio signals. Radio waves travel at the speed of light and can cross enormous distances. If we were listening at the right frequency, at the right time, pointed at the right part of the sky, we might hear something. The Big Ear Observatory was not glamorous. It wasn't the kind of telescope you see in films, the famous dish at Arecibo, or the sweeping arrays in the New Mexico desert. The Big Ear was flat, a large reflective surface on the ground, angled to collect radio waves from space as the Earth rotated. It was low budget, operated on a shoestring, and its volunteers checked printouts that came off a line printer. Paper rolls of data, columns of characters reviewed by hand. Jerry Ehman was one of those volunteers. He had been doing this work for years. He knew what noise looked like. He knew what nothing looked like. And on that August morning in 1977, he saw something he didn't recognize. To understand why the wow signal was so strange, you have to understand what scientists were listening for. In 1959, physicists Philip Morrison and Giuseppe Cocconi published a paper in Nature magazine. They argued that if an alien civilization wanted to send a signal another civilization could find, they would broadcast at a very specific frequency, 1420 megahertz. This is the frequency at which hydrogen, the most common element in the universe, naturally emits radio waves. Any civilization advanced enough to build a radio telescope would know this frequency. It would be the logical choice, a universal channel already known to every technological civilization everywhere. The Big Ear was scanning near this frequency. The signal that Ehman found was broadcast at 1420.46 megahertz. That alone wouldn't be remarkable, but the signal had other properties that made scientists stop. It came from a single point in the sky, not spread across multiple directions the way terrestrial interference usually behaves. It lasted exactly 72 seconds, the precise window during which a fixed point in space would pass through the Big Ear's field of view as the Earth rotated. Any shorter, it might be noise. Any longer, it might be a local source. 72 seconds was exactly right, and its intensity, the strength of the signal, was extraordinary. The printout used numbers and letters to represent signal intensity. Numbers ran from 0 to 9. After 9, the system switched to letters. A for 10, B for 11, and so on. Most background signals registered as 1s and 2s. Background noise was quiet. The universe, for the most part, is quiet. 6 EQ-UJ5, 6, then EE14, then Q, 26, then U, 30, then J, 19, then 5. That curve, rising steeply, peaking at 30, then falling away, is called a Gaussian curve. It is the exact shape you would expect if a radio telescope swept across a fixed point in space as the Earth rotated. The signal strengthened as the telescope moved toward it, peaked as it centered, then faded as it passed. In the precise technical language of radio astronomy, it was a perfect signal. Every parameter scientists had predicted for an extraterrestrial transmission, frequency, bandwidth, duration, intensity profile, point of origin in space, the wow signal matched all of them. The frequency was in the protected hydrogen band, a part of the radio spectrum that international treaty designates free from terrestrial broadcasting, precisely because it's scientifically important. No earthly transmitter should be there. Satellite interference was ruled out. Aircraft was ruled out. The signal came from the direction of the constellation Sagittarius, a region of sky containing billions of stars. Ehman checked the columns again, then again. He circled it. He wrote, "Wow!" And he went home and waited to hear it again. They never heard it again. In the weeks after Ehman's discovery, the Big Ear telescope turned repeatedly to the same region of sky. Nothing. SETI programs around the world were alerted. Other telescopes swept the same coordinates. Nothing. Over the following decades, increasingly powerful instruments scanned that part of the sky thousands of times. The WOW signal has never repeated. This is one of the most confounding aspects of the mystery. Most natural astronomical phenomena, pulsars, quasars, flaring stars, are regular or at least detectable across multiple observations. A signal that appears once perfectly, then vanishes, is not consistent with any natural source scientists have identified. It is also not consistent with a confirmed extraterrestrial transmission, because a civilization broadcasting into space would likely broadcast continuously or at least repeatedly. In 2016, a group of astronomers proposed an explanation: a comet. Two comets were near that region of sky in 1977, and hydrogen clouds trailing comets can emit radio energy at the right frequency. But when the same team looked for a WOW signal signature from active comets using modern telescopes, they couldn't reproduce the effect. The comet hypothesis remains contested and is not widely accepted by the scientific community. The signal sits in a category by itself: not confirmed alien contact, not explained away. Just there. Once. Perfect. Gone. What Jerry Ehman found that morning didn't just puzzle scientists. It changed how SETI was funded, focused, and taken seriously. Before the WOW signal, SETI operated on the fringes. Serious astronomers were often reluctant to associate their names with it. The idea of listening for alien broadcasts sounded too much like science fiction. Interesting, harmless, but probably pointless. After the WOW signal, it became impossible to dismiss entirely. In 1988, Congress held hearings on SETI funding. The WOW signal was referenced repeatedly as evidence that searching was worth the cost. In 2016, when scientists detected an unusual signal from a star 94 light-years away, one that briefly dominated global headlines as a possible alien transmission, the WOW signal was the frame everyone reached for. It was the thing people compared it to. Jerry Ehman himself was careful. He never claimed the signal was extraterrestrial. He said it was consistent with an extraterrestrial origin. He spent the rest of his career explaining precisely what the data showed and what it didn't prove. "I am still waiting," he said in a 2010 interview, "for someone to find a natural explanation that fully accounts for what we recorded." He died in 2024. The signal remains unexplained. The Milky Way contains between 200 and 400 billion stars. Astronomers now know that most of those stars have planets. The number of Earth-sized planets in habitable zones, close enough to their star for liquid water, is estimated in the billions. The universe has been around for 13.8 billion years. Life on Earth took roughly 4 billion years to go from single cells to radio telescopes. If life started early on even a small fraction of those billions of planets, and some of those worlds are billions of years older than Earth, the mathematics of probability suggests that civilizations capable of broadcasting radio signals should exist somewhere. The Fermi paradox asks the obvious question: if they're out there, where are they? Why haven't we heard anything? Maybe we have. For 72 seconds, on August 15, 1977, the Big Ear telescope picked up something it was never designed to find. Something that matched every criterion for what a transmission from another civilization would look like. Something that came from deep space, at exactly the frequency physics predicted, from a region of sky containing billions of stars. And then silence. The original printout still exists. It is kept in an archive. The circled characters, the red ink, the word WOW in Jerry Ehman's handwriting, all still there. It is one of the most analyzed pieces of paper in the history of science. And it still doesn't have an answer. The universe is vast. It is old. And we have been listening for a very short time with limited instruments pointed in specific directions for only a few decades. The fact that we haven't confirmed contact says very little about whether contact is possible. One night in 1977, for 72 seconds, something came through. We don't know what it was. We don't know where exactly it came from. We don't know if it's still out there, still transmitting, still waiting for someone to answer. But for 72 seconds, the universe was not silent, and we almost missed it.